Before we get into today's lesson about disjunctions, I want to have a quick review about conjunctions, and that's the concept that we covered right before we went on the Thanksgiving break. So let's go ahead and do a quick review. Conjunctions are a compound sentence of mathematical statements that are connected by the word and. The solution to a conjunction is the intersection of both of those inequalities. So let's go ahead and look at an example that I have prepared for you. So I have this example, x is greater than -1 and x is less than or equal to 4. And remember that we use this symbol, which looks like an upside down V, to symbolize the word and. Well, when we graph this, we have to make sure that we graph each inequality separately above the number line, like I've done here. Here I have in red, x is greater than or equal to greater than -1. Remember that this open circle, it's not filled in, so that means that it's not equal to that number. So x is greater than -1. So anything that's to the right of -1 would be bigger, so I want to shade in that portion. And in blue, I graphed above the number line, x is less than or equal to 4. And since this says less than or equal to, I'm going to shade in that circle and shade everything that's to the left of 4. And remember that the intersection is what they have in common. So I'm going to look here and I see, oh, they have everything from -1 to 4 in common and nothing else. So that's what's going to go on my number line, and that's what you see here in purple. Alright, so now that I've refreshed your memories about conjunctions, let's move on. What is a disjunction? Well, they kind of sound the same, conjunction, disjunction, and you know what? They're going to be kind of like opposites. A disjunction is going to be a compound sentence of mathematical statements connected by the word or. So instead of connecting by the word and, like a conjunction, disjunctions use the word or. So what that means is that the solution can be any one of the statements. It doesn't have to be both of the statements or their intersection. It can be one part of the sentence or it can be the other part of the sentence. Now, for a disjunction to be true, only one of the statements in that sentence has to be true. And the solution to a disjunction is the union of the solution sets. And if you remember when we first started talking about intersections and unions, the union was everything that was contained in that set. Remember when we had the brackets at the beginning and we said that the union within these sets was all those numbers that they contain. While the solution for disjunction is going to be the union, all of the numbers that are contained there. And when we graph disjunctions, we graph them basically the same way that we do conjunctions. So let's take a look at how we do that. So write down these steps for graphing a disjunction. The first step is that we're going to graph each statement separately above the number line. Each part of the sentence, we're going to put that separately above the number line. And then we're going to identify the union of the two graphs, and we're going to graph that union on the number line. We're going to see what numbers basically are there that we can put on the number line. And then we're going to write the solution for the union. Alright, so let's get ready and do an example. So we're going to take this disjunction that says x is less than 4 or x is less than or equal to 2. Now what I want to show you is that this symbol right here, which looks like a letter V, that's the symbol that we use to symbolize disjunction, to symbolize the word or. So with a conjunction, that symbol was an upside down V. For a disjunction, for the word or, that symbol is going to look like a letter V. So let's move on. Now remember I said that when we graph these, we graph the statements separately above the number line. So I'm going to take x is less than 4, and I'm going to graph that separately above the number line. So I'm going to put an open circle above the number 4, and because it says less than, I'm going to shade into the left, because all those numbers to the left are numbers that are smaller than 4. And then I'm going to take the second part, or the next part of my disjunction, and that one says that x is less than or equal to 2. So because it says less than or equal to, that means I'm going to have a closed circle. So I'm going to put that closed circle above 2 and shade in everything to the left, because it's anything that's less than 2. So all those numbers are to the left. Now if you notice in purple, what I did was I graphed on the number line the union of those two statements, or the union of the disjunction. And the union is all of the numbers that are contained in there. So that's going to start at 4, starting at the number 4, going all the way to the left. Okay? So on the number line, open circle on 4, and everything to the left gets shaded in. And we say that the solution is x is less than 4. The solution is going to be what we actually put on the number line. On the number line, I'm showing that I'm starting at 4, and x is anything to the left. X is less than 4. And that's what the solution is for this disjunction. So now let's go ahead and try another one, but this one's going to be a little more involved than the one that we just graphed. This one's more involved because, as you can see, I have both sides of the inequality, or actually one side of the inequality that would need to be worked out before I can get an actual inequality where x is either greater than or less than some number. So what we have here is 3x plus 4 is greater than 16, or, remember that symbol means or negative 5x is less than or equal to 20. So remember that we have to solve one side before and get x alone before we can graph anything. So following the rules, remember we have to add and subtract before we multiply divide. So that's exactly what I'm going to do. Because 3x is adding 4, I'm going to subtract 4 on both sides to keep it balanced. So that's going to be 3x plus 4 minus 4 is greater than 16 minus 4, or, and I have to work with the second statement, this was negative 5x less than or equal to 20, and because here I don't have any addition or subtraction, I'm going to go ahead and divide, because my x is multiplying by 5, so I'm going to divide by negative 5 on both sides to keep that balanced. So let's move on and see what we have left. Now for the first part of the disjunction, I have 3x is greater than 12, or x is greater than or equal to negative 4. If you notice, the symbol here changed. Does anybody remember why that symbol changed, why it flipped around? Because I was dividing by a negative number. Remember, when you divide by a negative, the inequality flips to the other direction. Well, now what we have is this side of the disjunction is solved. That part can be graphed, but I still have this first part that I have to work on. So I'm going to continue till I have everything complete. Now, x is being multiplied by 3, and to get x alone, I want to go ahead and divide both sides by 3. Okay, when I do that, I'm left with x is greater than 4, or x is greater than or equal to negative 4. Alright, and if that last explanation was a little too fast for you, I encourage you to pause the video, rewind it, and replay this section. And make sure that you get everything down in your notes. That way you have a better understanding of it. You know, if there's anything you don't understand, what's great about the video is that you can stop and rewind and replay as many times as you need to. Well, now we're going to take this disjunction and we're going to go ahead and we're going to graph it. So the disjunction x is greater than 4, or x is greater than or equal to negative 4. is going to go above the number line, like so. In blue, I'm showing x is greater than 4. Remember that an open circle is not equal to. So I have an open circle there, and if x is greater than 4, that means x can be 5, 6, 7, 8, 9, so on and so forth, so I shade in everything to the right. And the second part of the disjunction is x is greater than or equal to negative 4. So that means I'm going to start on negative 4 with a closed circle, because remember this was equal to, so that means it can also be 4. And I'm going to shade in everything going to the right of the negative 4. Now on my number line, what I'm going to put is the union. And the union is all the numbers that I'm using. So I'm using everything starting from negative 4 going all the way to the right. And that's what we see here on the number line in purple. And that's the graph of x is greater than 4, or x is greater than or equal to negative 4. Now what's the solution? The solution isn't this whole disjunction right here. The solution is actually what I put on the number line. And on the number line, it's x is greater than or equal to negative 4. And remember what I said a few slides back. I said that the solution, in order for a disjunction to be true, the solution can be one of the statements. And if you look, this statement right here, x is greater than or equal to negative 4, is the same thing as the right side of the actual disjunction. So that means that this is actually going to be a true solution and a true disjunction. So now what I want you to do is take these two examples that I have, and I want you to write them down, and I want you to solve them. I don't want you to graph them, just solve them. So you're going to have x is greater than a number, or x is less than a number, x is greater than or equal to a number, x is less than or equal to a number. And I just want to see that you've worked both of these problems out, but I don't want you to graph them, okay? Just simply solve them. And that's going to be all for this video, for this lesson on disjunctions. So remember that if anything, you didn't get down or you were confused about, you can make sure that you rewind the video, play it as many times as you need to, so that you get an understanding of disjunctions. Thank you. Bye-bye.